Types of geometrical isomerism. Either a geometrical isomer will be cis or the geometrical isomer will be trans. Cis isomer has similar groups or same type of groups on the same side, and trans isomer has same type of groups on the opposite side of the double bond. For example, we have few examples of cis and we have few examples of trans. Let's check out. So what you see here is double bonded carbon atoms are here. So if we draw a line here, you can see methyl and methyl on the same side and hydrogen on the same side. So same groups on the same side, it is cis. Similarly here, if we see methyl and methyl are on the opposite side, diagonally opposite side. Similarly hydrogen and hydrogen are diagonally opposite side. If same groups are on the opposite side, it is trans. If same groups are on the same side, it is cis. Similarly here you have hydrogen and hydrogen on the same side and ethyl on the same side, it is cis hexene. Similarly here you have ethyl on the opposite side, same as with hydrogen on the opposite side. So it is trans hexene and it is cis hexene. Next we have chlorine atoms on the same sides and hydrogen atoms on the same sides. So this is cis, and here you have chlorine atoms diagonally opposite to each other, same as with hydrogen atoms diagonally opposite to each other. So this is another example of trans. So we have taken few examples of cis and few examples of trans. I am very sure that you must be clear by now which is called as cis and which is called as trans. Now if we check out the physical properties of these cis and trans isomers, then let me tell you that trans isomer is more symmetrical. Trans isomer has a symmetry, so symmetry always leads to higher melting point, whereas cis isomer has greater dipole moment, so it has greater boiling point. So cis isomer has greater boiling point and trans isomer has greater melting point. Cis more boiling point, more dipole moment. Trans more melting point, more stability. Yes, trans isomer is more stable than cis isomer. Let me tell you why. See, here we have two bulky groups, methyl and methyl on the same side. So repulsion is very high in cis, whereas in trans what is there? Methyl group are opposite to each other. So methyl groups are opposite to each other. As you can see, these are relaxed condition, whereas here there is tussle between two methyl groups, they are ready to fight. So this is not stable, whereas this is stable. So trans isomer is more stable than cis. So what we have learned here, melting point is high for trans, stability is high for trans, boiling point is high for cis, dipole moment is high for cis. So that is it for now. Thank you.